variations on a theme, and today we're going to have a look at reservoir sampling. Reservoir sampling is going to be the theme, and we're going to look how we can use the variations of that theme in scenarios where we need to use random integer or random number generation. So let's have a look at the first question. Question lead code 398 random pick index. Flagged as medium. Given an array of integers with possible duplicates, randomly output the index of a given target number. You can assume that the given target number must exist in the array. Note the array size can be very large. Solution that uses too much extra space will not pass the judge. Example, int nums equals new int 1, 2, 3, 3, 3. Solution equals new solution. Pick 3 should return either index 2, 3, or 4 randomly. Each index should have equal probability of returning. Pick 1 should return 0, since the array only nums 0 is equal to 1. Solution, pick 1. And next up is linked list random node. So again, we have random as being like the connecting tissue between those two questions. 382 linked list random node. Medium. Given a singly linked list, return a random node's value from linked list. Each node must have the same probability of being chosen. Follow up. What if the linked list is extremely large and its length is unknown to you? Could you solve this efficiently without using extra space? Example. List node head, list node 1. Head next, list node 2. Head next, list node 3. Solution equals new solution head. Get random should return either 1, 2, or 3 randomly. Each element should have equal probability of returning. Solution, get random. Okay, so key between both applications is that you need to have a look at the wording that says it can be really large. And that's like kind of a key thing for reservoir sampling, that you have like a limited space that you want to keep track, but you have a very, very large data set that you want to sample a value from, or that you want to randomly go to a certain position in that array and then get this particular value. Or you might not even know how large is it. You might just have like a coherent stream coming in all the time. You want to like randomly access that stream. Today's definition for reservoir sampling comes from geeks.org, which is a website and computer science portal for geeks. Reservoir sampling, they say, is a family of randomized algorithms for randomly choosing k-samples from a list of n items. And then they say typically n is large enough that the list doesn't really fit into main memory. For example, when they say queries on Google and Facebook. So we are given a big array or stream of numbers to simplify, and we need to write an efficient function to randomly select k numbers where 1 equals smaller equals k, smaller equals n. So then they first provide like a naive solution, which we will not spend too much time on. We just know that if we don't be more efficient about it, we get like k squared and k is the maximum size, which they say can get tricky once the reservoir size gets too large. So then the actual best solution is outlined as follows, and it can be solved in O of n time, which is helpful. The solution also suits well for input of the form stream. So when we don't know when there's an end to an array. The idea is similar to the following. So then we have steps 1. Create an array of your reservoir size, 0 to k minus 1, and then just first put the first k items in that array immediately from the stream. The stream comes to you, just put all those items in there in the array, all first k items, and then the additional logic comes into place. one by one, consider now the following incoming items and generate a random number. A random number from 0 to the current item. And then if the random number happens to be within the range of 0 to k, so basically in the range of your reservoir size, then swap, or like take the current ETH item and put it into your reservoir position at j, and j is that index between 0 and k, your reservoir size. So like the stream might be at length 1000, and your reservoir, since it potentially might be large, might be at length 600, and you get a number 700, then you don't do anything. But if you get a number 300, you switch 300 with your current position. And that's basically how you do the switch. And so if j is in range 0 to k minus 1, replace your reservoir. And then this basically always keeps track and keeps a good balanced sample of your entire stream, just given a smaller reservoir size or smaller array size that holds your information. And then you basically are able to keep track using a random approach. With that said, let's have a look at both solutions. First, a random pick index. We have here a Java-based solution where the key reservoir sampling basically comes in the routine pick and the target. And here we have like basically n being the number of our final array length. And what we do here is like if the random number hits our specifications, if it's within our reservoir range, then we swap it. So here we say result equals that's basically our swap position, right? And that's how we keep track for the random picking index. Just keep sampling. And when the random sample hits the correct range, the range of our reservoir, we do our switch. And then this way we keep the new index in the reservoir. Then to the other question, linked list random node. We have a C++ solution, class solution with list node keep, and the solution list node head keep equals that. So if we initialize with a constructor, first keep is pointing to the head, and then we just do keep random. And here basically we see like almost exactly the same logic with our criterion. If our random value happens to be within the reservoir size, then we swap. That's all we do. Like we swap our content in the reservoir. The content, all we need to do is basically just point to where we want our next node to be. So it's like x equals dummy well, and then with dummy we just like keep continuing to go through the list, and then once our random value hits the value to be within our reservoir, temp equals 0, then we just point to that solution. And that's all to it. And then return x, we finalize. Return x, we finally return that random value that is the one that we have chosen throughout the list via reservoir sampling. And so the bottom line here is basically your array size from which you want to sample randomly might be large, might be really, really large, so large that you can't have it in cache. Your reservoir size might be small, but might also be large. And then all you basically need to do is sample within the range of your current array index. And then if that random sample happens to be within the reservoir size, then you just get that new value and put it into the reservoir. And then thereby keeping that randomly sampled value in your reservoir cache. And then whenever it needs to be queried, you can just query it immediately from your reservoir, the smaller array of size 0 all the way to k-1.